Only careful thinkers pass this. This separates intuition from real understanding. First question. What is the primary goal of the MapReduce paradigm? A. Process large datasets in parallel on clusters. B. Replace relational databases. C. Provide real-time analytics. D. Guarantee ACID transactions. Correct answer is A. Process large datasets in parallel on clusters. Second question. What role does the map function play in MapReduce? A. Aggregates results across nodes. B. Transforms input into key-value pairs. C. Schedules cluster resources. D. Stores intermediate data permanently. Correct answer is B. Transforms input into key-value pairs. Third question. What is the main responsibility of the reduce phase? A. Filtering raw input data. B. Combining values for each key. C. Distributing data across nodes. D. Handling failures. Correct answer is B. Combining values for each key. Fourth question. Why is MapReduce considered fault-tolerant? A. It retries failed tasks automatically. B. It avoids network communication. C. It uses in-memory processing only. D. It enforces schemas at write time. Correct answer is A. It retries failed tasks automatically. Fifth question. Which type of workload best fits MapReduce? A. Iterative machine learning algorithms. B. Low latency OLTP transactions. C. Large batch data processing. D. Interactive dashboards. Correct answer is C. Large batch data processing. Sixth question. How does data locality improve MapReduce performance? A. By caching results in memory. B. By running computation near the data. C. By compressing input files. D. By avoiding disk I/O. Correct answer is B. By running computation near the data. Seventh question. What is a common limitation of classic MapReduce? A. Poor scalability. B. High latency for iterative jobs. C. Lack of parallelism. D. No fault tolerance. Correct answer is B. High latency for iterative jobs. Eighth question. Why did newer frameworks like Spark emerge after MapReduce? A. MapReduce could not scale. B. Spark supports only streaming. C. Spark enables faster in-memory computation. D. MapReduce is proprietary. Correct answer is C. Spark enables faster in-memory computation. Ninth question. Which storage system is MapReduce most commonly associated with? A. Relational databases. B. HDFS. C. Key-value stores. D. Message queues. Correct answer is B. HDFS. 10th question. What programming model does MapReduce enforce? A. Declarative SQL. B. Imperative key-value transformations. C. Object-oriented pipelines. D. Graph-based workflows. Correct answer is B. Imperative key-value transformations. 11th question. What does ACID stand for in transaction processing? A. Atomicity, consistency, isolation, durability. B. Availability, consistency, integrity, durability. C. Atomicity, concurrency, isolation, distribution. D. Accuracy, consistency, isolation, durability. Correct answer is A. Atomicity, consistency, isolation, durability. 12th question. Why is atomicity important in transactions? A. It improves query speed. B. It ensures all or nothing execution. C. It reduces storage usage. D. It enforces schemas. Correct answer is B. It ensures all or nothing execution. 13th question. What does transaction isolation primarily protect against? A. Data loss. B. Concurrent access anomalies. C. Schema changes. D. Hardware failures. Correct answer is B. Concurrent access anomalies. 14th question. Which isolation level allows dirty reads? A. Read uncommitted. B. Read committed. C. Repeatable read. D. Serializable. Correct answer is A. Read uncommitted. 15th question. Why is durability critical after a transaction commits? A. To allow rollback. B. To ensure changes survive failures. C. To improve concurrency. D. To reduce latency. Correct answer is B. To ensure changes survive failures. 16th question. What trade-off do higher isolation levels introduce? A. Higher throughput. B. Lower latency. C. Increased locking and contention. D. Less consistency. Correct answer is C. Increased locking and contention. 17th question. How do distributed systems often relax ACID guarantees? A. By using stronger locks. B. By applying eventual consistency models. C. By enforcing serializable isolation. D. By avoiding replication. Correct answer is B. By applying eventual consistency models. 18th question. Which system typically requires strict ACID compliance? A. Analytics data lake. B. Log aggregation system. C. Banking transaction system. D. Event streaming pipeline. Correct answer is C. Banking transaction system. 19th question. What mechanism is commonly used to implement atomic commits? A. Write-ahead logging. B. In-memory caching. C. Schema on read. D. Batch compaction. Correct answer is A. Write-ahead logging. 20th question. Why are ACID transactions harder to scale in distributed systems? A. Network partitions and coordination overhead. B. Lack of storage options. C. Limited query languages. D. Small data volumes. Correct answer is A. Network partitions and coordination overhead. 21st question. What is a time series database optimized for? A. Unstructured text data. B. High-frequency timestamp data. C. Transactional workloads. D. Document storage. Correct answer is B. High-frequency timestamp data. 22nd question. Which access pattern is most common in time series workloads? A. Random row updates. B. Append-only writes with time-based queries. C. Frequent deletes. D. Complex joins. Correct answer is B. Append-only writes with time-based queries. 23rd question. Why do time series databases often use compression? A. To enforce schemas. B. To optimize storage and query performance. C. To guarantee ACID transactions. D. To simplify ingestion. Correct answer is B. To optimize storage and query performance. 24th question. What is downsampling in time series systems? A. Deleting old data. B. Aggregating data at lower resolution. C. Encrypting data at rest. D. Reordering timestamps. Correct answer is B. Aggregating data at lower resolution. 25th question. Which query is typical for time series analytics? A. Point lookups by ID. B. Time window aggregations. C. Multi-table joins. D. Graph traversals. Correct answer is B. Time window aggregations. 26th question. Why is retention policy important in time series databases? A. It enforces normalization. B. It controls data lifecycle and storage costs. C. It improves transaction isolation. D. It prevents duplicates. Correct answer is B. It controls data lifecycle and storage costs. 27th question. What challenge do high cardinality tags introduce in time series systems? A. Schema rigidity. B. Increased memory and index usage. C. Data loss. D. Lower ingestion rates. Correct answer is B. Increased memory and index usage. 28th question. How do time series databases handle late arriving data? A. They reject it entirely. B. They allow backfilling or reordering. C. They override existing data. D. They store it separately. Correct answer is B. They allow backfilling or reordering. 29th question. Which system is a typical use case for time series databases? A. User authentication logs. B. IoT sensor monitoring. C. ERP systems. D. Content management systems. Correct answer is B. IoT sensor monitoring. 30th question. What is denormalization primarily used for in analytics systems? A. Reducing storage. B. Improving query performance. C. Ensuring strict consistency. D. Enforcing constraints. Correct answer is B. Improving query performance. 31st question. What is the main cost of denormalization? A. Slower reads. B. Data redundancy. C. Complex joins. D. Limited scalability. Correct answer is B. Data redundancy. 32nd question. Why is denormalization common in analytical databases? A. They favor read-heavy workloads. B. They require strict normalization. C. They avoid batch processing. D. They support only OLTP. Correct answer is A. They favor read-heavy workloads. 33rd question. Which scenario benefits most from denormalized tables? A. High-frequency transactional updates. B. Complex ad hoc analytical queries. C. Small reference lookups. D. Highly normalized OLTP systems. Correct answer is B. Complex ad hoc analytical queries. 34th question. What risk does denormalization pose for data updates? A. Write amplification and inconsistency. B. Query latency spikes. C. Schema enforcement failures. D. Data loss. Correct answer is A. Write amplification and inconsistency. 35th question. How does denormalization affect storage costs? A. It always reduces storage. B. It increases storage usage. C. It has no effect. D. It eliminates indexes. Correct answer is B. It increases storage usage. 36th question. Why is denormalization often acceptable in data warehouses? A. Because data changes infrequently. B. Because ACID is not required. C. Because joins are impossible. D. Because schemas are dynamic. Correct answer is A. Because data changes infrequently. 37th question. Which design decision should precede denormalization? A. Query access patterns. B. Hardware selection. C. Programming language choice. D. User authentication. Correct answer is A. Query access patterns. 38th question. How can denormalization impact data lineage and governance? A. It simplifies auditing. B. It can obscure transformation dependencies. C. It enforces metadata standards. D. It eliminates the need for catalogs. Correct answer is B. It can obscure transformation dependencies. 39th question. How can denormalization negatively impact incremental data pipelines? A. It reduces storage efficiency. B. It requires recomputing large portions of data on small updates. C. It improves isolation levels. D. It eliminates schema evolution. Correct answer is B. It requires recomputing large portions of data on small updates. Last question. The hardest one yet. 40th question. When is denormalization a poor choice in data engineering design? A. When queries are read-heavy and predictable. B. When dimensions change frequently and require updates. C. When storage is cheap and abundant. D. When batch processing is used. Correct answer is B. When dimensions change frequently and require updates. Subscribe to test your skills every day.